All right, Algebra 3-4. I'm going to try to make this quick, but probably it won't be quick. So, this is factoring, and these are similar problems to what you have. I guess the one thing that I'm noticing though that I forgot is that y'all have like f of x equals and like g of x. That doesn't really matter. We're gonna solve it the same way, but just for fun. And then it also says on page 10 to find the x-intercept. So I guess we'll talk about that too. All right. So for factoring, everyone has their thing. I like this model. And I know some other teachers don't like that, and that's okay. So I put my A term here. My B term goes in the middle, and then let's do this. My C term goes here. So this is A, B, C. So then that's like what I already know. And then I need to sort of find my, let's do like a highlighter. I need to find my side lengths because whatever I'm multiplying together gives me my inside box. So we're finding the factors. So that's called factoring. Okay, so for this coefficient of 2, it's a prime number. So I'm going to force one side to be 2. And that's nice. So like for problem number 2, same thing with 3. I can force one side. So the other thing I'm thinking about is the factors of 9. So I have 9 and 1, I have 3 and 3. I have a positive b value, which means that I probably have a higher, like whatever the higher value is, it needs to be positive. So I'm going to have one positive and one negative, just like for the record. And the other thing I'm thinking about is 2 and 3. They have a relationship of 6, right? And 6 and 9 are related by like just a jump of 3. So I'm going to try my factors of 3 and 3 first and see what happens. So let's do pink. So I'm thinking that if I do plus 3 here and then minus 3 here, that will work. So I get, let's do purple, negative 3x. Here I get positive 6x. And then what I need to have happen, I'll use black I guess, is these need to combine to be 3x, which they do. So my factors are 2x minus 3 times x plus 3. And again, that's like with our f of x. Sorry. And then the last step to find our x-intercepts, I'm going to sort of move that up for a moment. So the x-intercepts are when, what do I want to say? It's like when your output is equal to 0. So it's like this. And then I can solve here. So you might not need to do these steps all the way, like plus 3 divided by 2, so 3/2. And then this one, if I plug something in there to be 0, it has to be negative 3. So your x-intercepts, are the things that are going to make one of the parentheses be 0. So like one of these, right, if I plug that in, it's going to be 0. If I plug this in, it's going to be 0. Yep. Okay. Well, yeah. Let's go to the next one. I hope I explained that well. So I'm going to zoom in to start. All right. So same thing here. Why don't I set it up in black? So the things I know I have 3x squared. I know I have negative 2x, and then I know I have negative 5. So here my c value is negative, right? And this is A, B, C. And so same thing, I'm going to figure out what is going on with that first term, my leading coefficient. So I'm going to force one side to be 3, because it's prime. The other thing I'm thinking of here is that I have just 5 and 1. So one of these spots has to be 5 and one of them has to be 1. Like it just has to mathematically. The other thing is that I have a negative symbol again. So same thing, because of this -5, I have a plus and a minus. Okay, so I have a negative 2. So then if I put a 5 here, that would be 15. And that's too big for my 2. So it's not that. So I'm going to erase that. So then I'm going to put it over here. And I think I'm going to do -5 here. So that would be -5x. So see, I'm closer to getting my -2. So then that must be, well, 1 over here, plus 1. So then, let's use a highlighter. I want to see if this really does work. So let me show that step. So I'm saying that 3x minus 5x, like, does that equal -2x? -2x equals -2x. Yes, it works. So my factors for g of x, we'll say, are 3x minus 5 times x plus 1. And then same thing for my x-intercepts. It's when it's equal to 0. X plus 1. So these are to find x-intercepts. Sometimes you can see them though, just like for the record. So here it's like whatever this is has to be equal to 0. So I solve plus 5 divided by 3, 5/3. This one is just the opposite. Okay. Questions? So these are prime numbers mostly, so that's sort of why they're nicer to work with. Let's look at the next slide, and I know it's already 7 minutes. Sorry. Oh, these ones are nice. Okay. So for this one, I don't have a b value. It's 0. Isn't that so funny? So I'm still gonna, that's why I like this model, because you can see it. So I have 25 and 1, I have 5 and 5. Because there's 0, I'm thinking that it's gonna be 5 and 5. So I'm gonna set that up. The other thing is that the 4, right, so like this box, so 4 has 2 and 2 and 4 and 1. Again, because it goes to 0, I'm thinking it's gonna be the same numbers. So let's try that. I guess I'll keep that. 2x, 2x. And then let's do teal. It's negative though, so if I have a negative, remember I have negative and positive like as my options. So that's going to be -5 plus 5. So that would be what? 10x. -10x. There it is. There should be. So again, if I were going to check this and be like a fantastic, oops, I don't want a highlighter, I want a pen. So minus 10x, oops, does that equal 0x? 0x equals 0x, yes. Okay, so this is a funny, well, it's not funny. It's a special relationship. So, oh, we didn't do this. What are the other letters? We have like a p of x. Again, not that it really matters, but, and then let's say f of x. Just for consistency. Okay, so p of x, when I factor it, is a difference of squares. You'll see this in your work, so that's why I wanted to do that. So this is called a difference of squares. Yay! Okay, and then you get a nice relationship for the x-intercepts. Right, so each of these set equal to 0. It's going to be the opposite. Plus 5 divided by 2. X equals 5/2. Minus 5 divided by 2. Oh, they're just opposites. They're friends. Cute. Okay. For this one, it's kind of off center, hey? I'll draw it over here, I guess. So this one has some 4s in it. I can't factor a 4 out though because that C term isn't a multiple of 4. All right, so I see some 4s. Here's the thing about 1. You just have 1 and 1, right? It's its only factors. For 4, I have, so again, I'm talking about this one up here. This 4, I'm talking about 1 and 4 and 2 and 2. Because I have this happening, right? Because I have the 1 and 1, I'm thinking that I'm going to need this 2 and 2 to get to my 4. That's what I'm thinking. So let's try that. 2x, 2x. They both need an x, right? Because x times x is x squared. And then this has to be 1 and 1. One thing I want to say about this. So b equals -4. C is +1. So I'm going to have 2 negatives. Let's make that a semicolon. So -1, -1. I know. -2x, -2x, because when I join them together, I get -4x. Okay, I gotta zoom out. So, bon, ça va. F of x, this is so, equals, I can rewrite it in factored form. But look, this is just the same thing. So this, my friends, is a perfect square. Cute, we love it. So actually I can write it like this because it's just 2x minus 1 times itself. And then what's nice about the x-intercepts is that when I have that, I'll write it out like this though first. Right? I'm going to have the same thing happen because they're literally equal. +1 divided by 2, x equals 1/2. So then x would also equal 1/2, right? So I only have one root. One unique root or x-intercept. It's 1/2. Cool. All right. This one, the only thing I wanted to show you is that, and again, let's put a letter out front, just like h of x. Okay. So the thing that you can do for these is pull out a 6. So if I have a common factor, I can factor it out. And sometimes that is nice because look, this thing is maybe more manageable to us than having to deal with this a value bigger than 1. So then what would happen is I'm going to like take this and use my little box and circle. Boop. And look, it's 10 and 1. Everything's positive. Oh my gosh, it's beautiful. X and x. 10 and 1 because 10 plus 1 is 11. We love that. It adds up to be the right thing. So, I'm just going to go with the highlighter. I'm going to commit 6 times, and then I'm going to have my 2 factors out front. Or sorry, out back. Well, whatever. Right? So the 6 doesn't affect my roots, which is really actually powerful for us in math land here. So for my x-intercepts, I'm still going to have that 6 because it's just another multiplication step here that's happening to us. So I'm only going to check this. So it has to be the opposite. Okay, well that's a 0. Oh my gosh, well, you get the idea. -1. Yeah? Okay, so sometimes things are not as they first appear. So just be mindful of that. And then make sure that like your x squared is only like inside your factoring structure. So even if you're doing the box and diamond method, same thing, like your x squared is inside. Your binomials, it's true, go on the outside. All right, that was kind of long, sorry, but I hope it helps. And then you're working on page 10. So like now, try page 10. Thank you. All right.